All right, ready to dive into something pretty amazing. You mentioned you were really interested in the future of medical diagnostics and VR and AR. And get this research from ICTER scientists, they published it in Biomedical Optics Express, and it might completely change both of those things. And it's all about seeing the invisible.
Oh, wow.
Yeah, we're talking two-photon vision, being able to actually see infrared light.
That's fascinating because infrared light is, it's everywhere around us, but we just can't see it, right? It's like this whole hidden world that we're totally missing out on.
Yeah, exactly. But these scientists, they're figuring out how to, tap into that hidden world. But how does it even work? Two-photon vision, it sounds like, I don't know, science fiction or something?
Well, so, normal vision, how we usually see, that relies on our eyes absorbing single photons of light. But with two-photon vision, like the name says, it involves absorbing two photons of infrared light, and they have to be absorbed at the same time.
At the same time, okay.
Yeah, it's like, imagine one photon doesn't have enough energy for us to be able to see it, but when two of them hit the same exact spot, their energy combines, and then boom, we can actually perceive it as visible light.
So we're basically tricking our eyes into seeing something that they shouldn't be able to see.
Exactly.
That's so cool. But why does this even matter? What makes two-photon vision so special?
Okay, so there are a few reasons. First, this light that we're perceiving, it's actually half the wavelength of the original infrared light, which means we're not just seeing the infrared light, we're seeing it in a way that creates these super sharp, really high contrast images. It's like the light is more concentrated, and that gives us much finer detail.
Oh, that makes sense. So it's like, I don't know, upgrading from an old TV to a 4K screen or something like that.
Exactly.
Okay, but one thing I'm kind of wondering about is, the brightness. If we're talking about making this useful for, I don't know, medical imaging or VR, we need to know how bright this invisible light actually looks.
Yeah, that's a great point. And measuring the brightness of this two-photon vision, it's been a big challenge until now. But this ICTER team, they came up with this really clever method. What they did was they used a beam of visible light just as a reference, and then they adjusted it until it matched the perceived brightness of that infrared light that they were testing.
Oh, so they kind of created a brightness scale that let them compare the invisible to the visible.
Exactly. That's a great way to put it.
That's really clever.
Yeah.
So what did they find?
Well, their findings are actually pretty huge. They were able to quantify the brightness of this two-photon vision using the standard units, like candelas per square meter. The same way we measure the brightness of, your computer screen or a light bulb. And what's remarkable is that these two-photon stimuli, they can reach really high levels of brightness, almost 670 CDMOA safely.
Wow. That's way brighter than I thought it would be.
Yeah.
So we're not just talking about barely detecting this infrared light. It could actually be like a source of illumination.
Exactly.
Wow. This opens up so many possibilities, especially for the things you're interested in, like the medical diagnostics and VR and AR.
Absolutely. And what's even cooler is this research, it's actually led to a whole new concept called two-photon retinal illumination.
Okay.
And this framework helps describe those two-photon stimuli and predict their luminance, which is, super important for developing any new technologies. It's like they've created a language to understand this new visual world.
Okay, hold on. I think we need to unpack this two-photon retinal illumination idea a little bit more. It sounds like, it's the key to making all of these incredible applications a reality.
It is, yeah. You're exactly right. Because it goes beyond just knowing that we can see infrared light. It actually lets us measure how bright we see it and then use that information to actually design new tools and technologies.
Okay, so if I'm understanding this right, this two-photon retinal illumination is like the foundation for everything. From really advanced medical imaging to, amazing mind-blowing VR experiences.
You got it. And the ICTER team's research, what they've done is they've laid the groundwork for all of those advancements by actually showing just how bright and how clear these two-photon images can be.
Okay.
But let's talk about those applications themselves. I know you're particularly interested in how this could revolutionize medical diagnostics.
Oh, absolutely. The potential to see things that are hidden right now with the traditional imaging techniques, that's mind-blowing. I definitely want to explore that further.
Think about this. Infrared light. It can actually penetrate way deeper into tissues than visible light can.
Oh, wow.
So with this two-photon vision, doctors could actually see things that, that are hidden right now from those traditional imaging techniques.
It's like giving doctors a superpower, right? They can look beneath the surface without having to do like invasive procedures. But what kind of things could they actually see that are invisible right now?
Okay, well, so many things. It's really exciting. Imagine like being able to check the health of the blood vessels in your eye, or like track how a neurological disease is progressing, or even find like early signs of cancer, and all without needing to do a biopsy or surgery.
Wow.
And because infrared light is less damaging to tissues than some of those other imaging methods, it could be a much safer way to monitor those sensitive areas like the eyes and the brain.
So we're talking about like earlier diagnoses, more accurate diagnoses, less invasive procedures, and maybe even safer treatments.
Right.
That's huge.
Yeah.
The researchers mentioned specifically something called two-photon microperimetry as a potential diagnostic tool. Can you explain what that is and how it works?
Sure. Two-photon microperimetry, it's basically a super sensitive way to map out the function of the different areas of the retina, which is, that light-sensitive tissue at the back of your eye.
Right.
So imagine being able to pinpoint exactly which cells in your retina are working properly and which ones aren't. That level of detail, it's so important for diagnosing and tracking conditions like glaucoma, macular degeneration, and even neurological disorders that, affect your vision.
That's incredible. So we're not just talking about getting a clearer picture of like the structure of the eye.
Right.
We're actually talking about understanding how well each part is working.
Exactly.
That could be a game changer for so many people.
Absolutely. And, while two-photon microperimetry has so much potential for medical diagnostics, the possibilities for VR and AR, they're just as amazing.
Oh, yeah, VR and AR.
Yeah. Imagine a virtual world where, it feels truly immersive because the visuals are interacting directly with your retina.
Oh, so instead of looking at a screen, it's more like that virtual world is being projected directly onto my eye.
Exactly.
Okay. I can see how that would be much more realistic and, more immersive than anything we have today.
Right. And remember we talked about how sharp and how much contrast there is with two-photon vision.
Yeah.
Imagine that in a VR experience. It would change everything from entertainment and gaming to training simulations and even therapeutic applications.
Can you give me a better picture of what that kind of VR experience would be like? What would it feel like to be in a virtual world that was powered by this two-photon technology?
Okay, well, picture this. You're wearing these lightweight, comfortable glasses, not like those big clunky headsets they have now.
Right.
And you put them on, and all of a sudden you're transported to this completely different world. But it's not just visuals, it's like a total sensory experience. The light and shadows, they interact realistically with your environment. The details are so crisp and so clear, you feel like you could reach out and touch them. You turn your head and the world moves with you instantly, seamlessly, like it was real. It's a level of immersion that we haven't experienced before.
That's incredible. I can see why people are so excited about what this technology can do. But as asked, are there any downsides or challenges that we need to think about?
Yeah, that's a really good question. And while the potential benefits are huge, we do need to acknowledge that, there are some challenges. This two-photon technology, it's still pretty new and it's expensive.
Oh.
Making it available for medical use or for consumers, that's going to take time and more development.
Right. And I imagine there's still a lot we don't know about the long-term effects, even if it seems safe in the short term. What are researchers doing to address these concerns?
Yeah, that's definitely something they're looking into. Scientists, they're actively investigating, what happens with repeated exposure to infrared light, even at low levels, just to make sure that these technologies are safe and that they can be used responsibly.
Yeah.
They're also trying to find ways to make the technology cheaper and smaller so it can eventually benefit everybody.
That's good to hear, that they're making sure that it's safe and that everyone can use it. But even with those challenges, the potential of this two-photon vision, it's undeniable. It really does feel like we're at the beginning of a whole new era of visual perception.
I completely agree. And, this brings us back to what the ICTER team actually did. Remember that breakthrough they had in figuring out how to measure the brightness of these two-photon stimuli?
Yeah.
That's what makes all these potential applications possible.
Right. It's not just about seeing the invisible. It's about understanding it and measuring it so that we can use it to build these next-generation technologies.
Exactly. That's where the two-photon retinal illumination comes in. It gives us the framework to actually design and develop these new tools and devices, things that can use two-photon vision safely and effectively. It's like building the foundation for a whole new technological landscape.
So the science is there, the applications are amazing, and now we have the framework to make it all happen. This is really revolutionary. This has been like a really eye-opening deep dive. It's incredible how much we can learn from just one research paper, especially when we have, an expert to walk us through it.
Well, the credit really goes to those researchers at ICTER. They're doing some amazing work. They've opened up this whole new world of possibilities, and now it's up to us to explore it further.
And speaking of exploring, I have one more question before we wrap things up. We've been talking about seeing infrared light, but could this two-photon vision, could it let us see, I don't know, other invisible parts of the electromagnetic spectrum?
That's a really interesting question.
Yeah.
And while, extending this two-photon vision beyond infrared light, that definitely has some technical challenges.
Yeah.
The theoretical possibility is there. There's just so much we still don't know about the universe and how we interact with it using our senses.
It's kind of humbling, but also really exciting.
Yeah.
Thank you so much for sharing your expertise with us today. I feel like I have a whole new perspective on this invisible world around us.
Oh, it was my pleasure. The most important thing is to always stay curious and never stop exploring. Who knows what other incredible discoveries are out there, just waiting for us to find them.
It really makes you think.
It does.
Well, that's all the time we have for today's deep dive, but I want to thank you all for listening. If you enjoyed this episode and want to hear more, be sure to subscribe to the show and leave us a review. And as always, keep those curious minds engaged, folks. Until next time.